Inequalities. We are going to, we did this last year. We did this yesterday. We're going to solve inequalities, but I'm going to teach it in a way that you don't memorize. You think.
Camera, Mrs. G.
There. Keep going. Okay. We're going to solve one-step inequalities. Yeah, I'm recording it. Okay. Okay, you guys? Headsets off. She's going to take her headset off, too. Headsets off. Only thing you should have open is Notability. And not that. Get your Notability up. But I'm not going to wait. Okay. Good. What does it mean to solve? No, that's fun. Okay, it's partly right. Find the value of x that does what? What do you mean solve the problem? I don't understand. No, you want to be in lessons. Very good. We're going to do 5 and 6. Okay, open up Notability. Okay, we want to find the number or numbers that make the sentence true. If we know that, we can solve anything. Okay, Matt, you're not going to know how to do this if you're not paying attention. No, it isn't. Find the number, not correctly, or numbers that make the sentence true. You know why I know that? Because even in calculus, they don't do this right. I have to reteach exactly what I'm doing now. And they get it. Now, some people think that when I solve that inequality, that this points in the right direction. Not always, so you have to be careful. So I don't like to use that at all. Okay? China, headset off, please. That's much better. Because if you don't pay attention, you're not going to get the next lesson. Do we have both ears out? Okay. Okay, we want to solve this inequality. What does that say in English, Jens? What does it say in English? Make the sentence true. I forgot the true part. Sorry. What's X?
This isn't in English.
What does X stand for?
It's greater than.
What? Wait. What is X?
Wait. It's less than or equal to.
No. What does X stand for? We don't have that part right. A number. In fact, I want to find all numbers. Okay, if you guys are going to chit-chat, go to the SBI room. All numbers that are less than, what's the little bar underneath mean, Matt? Don't help them out. Or equal to 3. We're going to learn a boundary method today. And then it's going to be easy. Can you give me some numbers that are less than or equal to 3? Matt? 1. Yeah, you sure did. -3 is good. 2.
Any other number under 3?
How about a half?
Sure.
What did you say? 1.5 decimals too. Could I list them all? Katie, I want you focused here. Kate, I want you focused here.
It's infinite.
If you guys pay attention in class, it's easy. If you don't pay attention, it's not easy. You're going to do it your way. Your way works 50% of the time, probably. So do it my way, and you'll get it right all the time. How many numbers are less than or equal to 3? Infinite. There's a whole bunch of numbers. Can't count them all. So what we're going to do is we're going to draw a line. So I'm going to put a line here. And what's the question? Why am I teaching with a microphone? I'm recording this. Plus, my voice is bad. Okay. Now, this is the boundary right here. You make x equal to 3. So there's 3. Now, I'm going to put a circle here marking that boundary. I'm going to fill it in because it's less than or equal to. Okay, China? So I'm going to fill this in because it has that extra little line there. So there's extra filling. Now, that dot isn't any bigger than any other dot on the number line, even though I make it bigger, just so that we can see it and then we know where it's at. Then what I'm going to do is test the regions. Yes? All the time. This is on the MCAs. If you are a machinist, you're going to be doing what I'm going to do next in the next lesson, absolute value inequalities. You are going to measure a radius of something maybe, and you want to find that, make sure that the area of the volume is within a certain tolerance. So yes. Okay, now we're going back to this. I want relevant questions. I marked the 3, and Joey, okay, put your iPad down, and here's paper, and I'll get you a pencil if you're not going to work on it.
It brought something up on my screen.
No, it didn't. Okay, I don't know what it is anyway. Okay, now I have had a totally fractured lesson because of all these interruptions, which is not okay. I'm trying to teach this. This is a boundary point. It divides the number line into 2 parts. One side is true all the time, and the other side is false. That's why we're solving, trying to find all numbers that make that true. Well, what's the easiest number that you could test to see if it's true or false? Kate, that's harder. Joy said it, though. It works, by the way. Would you say, Joy? 0. 0 is the easiest number in the world. Put it on your number line in the right place. You have number lines. And then all you do is put 0 in here. You evaluate. Is 0 smaller than or equal to 3? Is that true or false? Remember, what does it mean to solve? To find numbers that make the sentence true. I'm trying to find all the numbers that make the sentence true. Well, if 0 makes the sentence true, everything on this side of that boundary make it true. So I will shade all of this. And just to be sure, why don't we try 10? Which just happens to be a number. Is 10 less than or equal to 3? No. So I will not shade that side. I shade only the side where it's true. Because if 0 makes it true, all these numbers make it true. Notice I put my number line here, because if I put it on the line, I can't necessarily see it. That's the problem. Kate. All these points, 2, 1, 1.5, we just said they all make it true, don't they? It doesn't go into 3. It goes into this sentence here, and if you put 2, is that less than or equal to 3? I can't list them because there's too many. So I have to draw a picture. That's what a graph is. It's a picture of all the numbers that make the sentence true. Okay, let's try another one. Numbers greater than -8. Do I get to include the -8? What's the boundary, by the way? What's the boundary? -8. See, that's the problem. You guys want to do the switching the signs and all that stuff. You never remember when you do it, when you don't. I'm not going to teach that at all. We're going to because when we get to the absolute value one, we have to be thinking what numbers make the sentence true. That's what we have to be doing. So where's the boundary there? China, we need to be working on math. And you should be writing on here. You should all be writing. Don't go ahead of me. Max, you're not going to do it right. Trust me. You're on the wrong lesson. We are on lesson 5. Now, do I get to include -8? Izzy, do I get to include -8? No. You had a 50-50 chance. Okay, what does this mean? This means I want numbers bigger than -8. Do I want numbers equal to -8? No. So if it had just said x equals -8, I would fill that in. That point is no bigger than any other points. In fact, -8 is not even graphed. It's an empty circle. Just looks like it's graphed. Now, what's the easiest number I can test in my inequality? Because I'm just going to do guess and check. Powers, what's the easiest number I can put in here and try it out? In this sentence right there. What's the easiest number in the world? 0. And it goes over here. I'll put on the wrong side. Is 0 bigger than -8?
Yeah.
Think? It's going to go down to 8 below tonight. Is 0 warmer?
Yeah.
Yes. Okay. So 0 makes it true. Then all of these numbers here make it true. Does 10 make it true? Remember, we're finding all the numbers that make it true. I could list them all, but I don't have enough time. I'll draw a picture. All those numbers. That's what that line represents. All the numbers that make that sentence true. Okay? You need to be paying attention. We're going to get the harder ones. This is one that you're going to mess up if you don't do it my way. If you do it your way, you're going to shade the wrong side. You know, how do I know? Because I've been teaching 35 years. I know. You will do the wrong side. Okay. We're going to solve this equation. 6 equals x. Where's the boundary? 6. That was pretty easy. Do I get to include it? Look here. No. Easiest number to work with? 0. So you put 0 in here. Is 6 smaller than 0? Now you can think this. You don't have to write it. I don't care if you write it. Kate, put your phone away, please. Is that true? No. So I'm not going to shave this side. Nothing here works. This is the place where either that side works or the right side works, and it's the right side that works. And if you don't believe me, put in 10. Any number you want. Put in 100. Is 6 smaller than 10? Yes. That means any number you put in here, China, I want you here in math, not whatever you're doing. Well, that's good because you weren't before. I want all these numbers work. All of them work. Now, you guys, if you want to do it your way you learn how to do it, I would turn this around and make it like that. And then it's easier. But you know what? You have to remember to turn it around. But I've seen many people graph the wrong direction. It's opposite what that symbol is. That symbol is not telling me the right direction. So don't do it that way. How about this one? Now we're going to, again, find the boundary. So you make it an equals. That's the boundary. So what's x equal to? Subtract 3, negative 4. So we draw our line, and I can cheat. I can draw a nice little line here. And we are going to mark, except we're going to, I'll just move it. There. We're going to mark negative 4. Put it right at the break there, no problem. Do I get to include it?
Yes.
Yes, I do. Lexi, do you see how to do this? And what number am I going to test? Oh, easier. I'm always going to test 0. Unless I'm at 0, in which case I can't do that. So 0's over here. And you put it in here. You always go back to the original. And what's that going to, is that true? Is 3 bigger than negative 1? Nicole? Is that true? Is it true, you guys? Yes, it is. You need to be working on math, Nicole. Okay, so yes, this made this true. So all these numbers here make it true. And you may think this takes longer than doing it your way. You'll do it my way and you'll get it right. If you do it your way, you won't get it right. We did, but I'm going to make sure you understand this because we're going to do absolute value next. Oh, I screwed up. Is it my, well, I didn't. No, I did. I subtracted 3. I showed my work there. Then I put in 0 and I tested. Does 0 work? Should we put in 10? Is 10 plus 3 bigger than or equal to negative 1? If 0 works, all of these numbers work. You give me any number to the right of 4, it will work. I took x plus 3 equals negative 1, and I subtracted 3 to find the boundary. That's the place that you go from true to false. You can, but you always get mixed up when you get negative signs. Let's do the next one. Kate? When you multiply or divide. But it's easier. And Powers, I know you're fighting me on this, but don't fight me on this because when I get to absolute value ones, you're going to do it this way. Because if you do it the way you were taught last year, probably taught before, yeah, you are. You don't want to do it this way. We are going to do this. Negative 2x equals 4. Okay, Joey, put that away too. Then why are you laughing at math? Because math isn't funny. Not funny. Okay. It happens. Okay, let me write this better. Okay, guys. Negative 2x equals 4. I don't remember if I add or subtract negatives. Chris, go. If you're not going to pay attention and you're going to talk, then I don't want you here. If you want to just sit quietly, fine. I don't care. That's your choice then. Now, when you're multiplying and dividing by negatives, you switch the sign. What if you add or subtract negatives? What do you guys do? You forget. Because that's memorization. This is understanding. Solve this. Here's what is x equal to. Where's my boundary? Divide by negative 2. What's 4 divided by negative 2? Same thing with you, Matt. Negative 2. So now I'm going to draw my line. I don't have to do any thinking now. Wow. Whoops. I'm not doing, that's an equals. That's the boundary. Do I get to include the negative 2? It doesn't matter. That's an equals. I could switch my equals. Yep. There it is, switched. Equals doesn't change. Equals. You guys aren't listening. This is an equation. We are going to, not this year, but we're going to be able to solve something like this. And you're not going to know what to do here. So we don't. We make it an equation. Throw out everything you've learned, because it's all going to come to be clear to you when I do absolute value. In this lesson from yesterday, yes. What? First, I find the boundary. This is the boundary. Okay, goodbye. I'm tired of hearing you up here. Goodbye. Go to the SBR room. I can. I have great hearing. He's very low voice. Now they're getting interrupted. Shh. Who? Who? Yes. I just couldn't hear. So when you do this one, Powers, you don't have Powers. You don't have a clue as to how to do that one. There are 4 inequalities you get from this. There are 4 inequalities you get from this. Can't multiply anything. No, you can't. You have to subtract 8, and you can't even do that. You have to do this. 3 over x plus 8 is less than 1, and 3 over x plus 8 is greater than negative 1. Yeah, I don't want to do that. This, and you can do it this way. Trust me, it's harder. Chris, I removed you. Please leave. And Matt's probably going to go with you. Matt, you need to put your phone away or pay attention. It's a choice.
Wait, why would you have to flip the sign?
We're not going to flip the sign. Let me do the problem. I'm not doing it that way. We are doing it as a boundary. Yeah, SBR room. Tired of hearing you guys. Okay, because I can hear you all the way up here. I know they can't. All of this is in the recording. Hope you're happy.
So, you said you had really good hearing, but you couldn't hear the speaker.
I was talking at the same time as the speaker. I don't know what they're saying. I could hear the voice. I didn't know what they said. Okay? Let's start again. I don't know what they're saying. I have no idea what they're saying. I couldn't hear the name that she asked, that she gave me. Okay. Okay, guys. Let's try this again. You find the boundary. And I don't care if you're doing it with an inequality. You still find the boundary. And then you test the regions. Okay, where's the boundary? We set this equal. Because then I don't have to remember anything about flipping anything. Do I? I'm dividing by negative 2. Where's the boundary? Where's the boundary? It's at negative 2. So she's got that. Do I get to include it, China? There's no line under here. So that means just less than. And then, so this is going to be an open circle. And then you try 0, which is over here. Why did I choose 0? Because it's easy. Is 0 smaller than 4? Yes. You don't check, you don't look here. You look right here. Is 0 less than 4?
Yeah.
I'd rather have 4 degrees than 0. Yeah. Boom.
Why would it be negative?
Because if you were to do it the way you've been taught in the past, you would divide by a negative 2. And when you divide by a negative 2, you remember that I actually have to flip this. Because Powers is what I'm talking about, you fighting me. Yes, you are. You can't do that absolute value equation with the tools you've been taught. Because I'm getting to absolute value. You haven't let me get there. Yes, you are. But use the tools, and I'll be marking them wrong when you get them wrong. I don't want to do that. I want 100%. Everybody 100% getting 100%. Yes, you will. If you do this, make it equal to 1. You'll see in the next slide. Nicole, what do I get? Nicole, you need to be focused on math. Again, I might take your iPad away too. If you're not going to have math on your iPad, you don't get your iPad, you'll have to do paper pencil. Sorry, but you know what? When you're in this class, you're supposed to be focusing on this class. And we're losing time. It means you're not going to have any time to get homework done because of all the arguments. No, meant to be done in class. You are, because you haven't let me get to the point where you can't do it the other way. Not right 100% of the time. Do it my way, it's 100% you'll get it right. Well, assuming you can solve an equation. What's x here? Joey?
I know it.
Okay, I'm wrong. You're not going to get right 100% of the time. You're going to multiply by a -3. What's x equal to? -3. Good. There's your boundary. Then you put -3 in here, and then is it going to include it or not? No. And then you find 0, which is over here, and is 0 divided by -3 bigger than 1? No. So I don't get to include that side. Because this is division. How do I undo division? Then I would divide it as multiplication. You do the opposite operation. It says some number divided by -3 is 1. Do I even need to show that work if I know what a solution is? No. I know what I divide by, what number I divide into to get a 1. I need a -3 there. Just by looking at it, I know that. That's perfectly okay. Okay, so Jens, which way do we shade?
You're gonna shit.
You need to be focused here. Is 0 bigger than 1?
Hold on a second.
Does 0 make it true? So we go the other way. That's it. No, that was yesterday's. Now we're going to open up the other lesson, because now we're going to get to the absolute value, and you are going to do it wrong if you try to do it your own way. No, that's not faith in you. I've taught, Jake, it has nothing to do with that. I taught calculus, and I have to reteach all of this to calculus students who have done it for 3 years. Okay? That's been my experience. When? You may have to take calculus. Depends on what you want to do. If you want to go to college, you're probably going to take calculus in college. You don't have a choice. It's hard. But you know what you have to know? You have to know all these. You guys bring it up. It's 0.6. And don't throw, Joy. Calculus is easy. This is the algebra that you use in calculus. So if you don't know the algebra in calculus, then you must learn the algebra. Do you want to go to the SBI room too? It's not funny. Okay, yesterday I wasn't here. I wasn't here for a reason that I had to go in for a medical test, and it had to be done yesterday. I don't know yet. I'm still waiting to hear. I'm not telling you. Because if it's a good, you don't need to know. If it's bad, I'll tell you. And it could be bad. Okay, we're going to do absolute value inequalities. There it is. How do you solve that, Powers? That's part of it. What's the other part? What about -7? X is less than or equal to -7? Nope, that's wrong. Kate. That's what I said, Kate. Nope, this is absolute value. So what we're going to do is we are going to solve the absolute value equation. We are going to find the boundaries. Because if you have absolute value of x equals 7, how many numbers make that true? 2. Joy, what are the 2 numbers?
-7.
Excellent. So we find the boundaries now. And then you test. And guess what? When there are 2 boundaries, there are 3 regions. You test the 3 regions. You will notice a pattern, and if you figure it out, that's fine. You may use it. But to do this correctly with inequality and all that stuff, with the 7 and -7, with the less than or equal to, everybody messes it up, and then you solve it wrong. So why don't you just do it my way? It's much easier. Where's the boundary? It's at -7 and 7. Do I get to include the 7s? Joey? Focus. Do I get to include this? Yes. Why? Because it's less than or equal to. Just think what it says. It says less than that number or equal to it. Now I have to test the regions. I really have to test all three, but let's start with the easiest number in the world to test. Just get a little confidence here, which is what? 0. Put it in here. Is the absolute value of 0 less than or equal to 7? Yep. That means all the numbers in between there make it true. Are there other regions that make it true? Maybe, maybe not. In this case, not, but I'll prove it to you.
So you have to have 2.
You will have 2 spots with absolute value, unless it's the absolute value of x equals 0. How many answers are there to that? No, there's 1. Okay, that's the only time that you get 1. So you know you're going to get 2. Okay, yep.
And if those two don't match, would they just be like opposite?
Well, we have to test all 3 regions. Let's find out. That's a good, very good question. Okay, so what number would you like to test bigger than 7? I like to go big. I like to go to 100.
600.
600 works. Is the absolute value of 600 greater than 7?
Yeah.
I'm sorry. You answered my question right. I wrote it wrong. It's supposed to be what? Less than or equal to 7. Is that true?
No.
Nope. So I don't get to shade that.
Well, no. Yeah.
What number, negative number, would you like to try?
Negative 300,000.
Negative 300,000. The absolute value of that. Is that less than 7? What is the absolute value of that?
That's less.
What's the absolute value of a negative number?
Oh,
It's a positive number.
I see.
Is that less than 7? No.
Wait, can I do one?
Sure.
Okay. No job.
He doesn't believe us. Make it decent.
Negative 300 million trillion.
Oh, I don't want to do that. Because it'll be positive 300 million trillion, and that certainly is not less than 7. Okay? How do you write your answer, though? Now, I don't know. I've got to see what the other teachers are doing, but I want all numbers, call them x, between 7 and negative 7. So it sits in an inequality like this. And I realize I forgot to do the other ones. This is a picture. That's how you write it without the absolute value. Let's try another one. And trust me, I get some of the other ones. Oh, this one's tough. What are you going to do with this one? We're going to pretend it's equals first. Yeah. No, wait till I'm done. You can wait. X plus 5, absolute value of x plus 5 equals 10. Are these going to be opposite numbers?
Yep. No.
X plus 5 equals 10. Because you know what? I know how to do this. Or x plus 5 equals negative 10. So what's x here? 5. Jans, what's this one? Not negative 5.
Negative 15. It was my question, Joey.
Okay, let's put the line in here. Okay, you guys, ready? Let's put the boundaries in here. Negative 15, 5. Okay, do I get to include them? No. Then I test. I have to test all 3 regions, honestly. But let's test 0 because that's easy. Is 0 plus 5 greater than 10?
Yes. I mean, sorry, no.
No. So that's not going to work. Let's try something over here. What would you like to try on the right? 17. Is the absolute value of 17 plus 5 bigger than 10?
Yes.
It's 22. Yep. So this works. And these are numbers that are bigger than 5. What about this one? And they're connected with an or, but I'm not going to be picky about that at all. So I'm not even picky about that in calc. How about what number we want to try over here?
Negative 2.
It has to be smaller than negative 15.
And or negative 20.
Negative 20. I want to keep the arithmetic somewhat easy. Is that bigger than 10? What is this going to give us? Negative 15. Is that bigger than 10? Yes, absolute values are positive. Is 15 bigger than 10? Yes, it is. And this solution is x is less than negative 15. That's how you do those. Don't have to worry about negatives. I don't have to worry about flipping the inequalities. And when you get to something complicated like the one I gave you, there are rules. If you have 1 over x is greater than 7, you may not multiply by x. X could be negative. And if x is negative, that flips. Okay, powers? Then I have to solve 2 inequalities. I don't want to do that. This way works every time. It works for any complicated thing you have, by the way. Okay, try that one. Who wants to come up and do it? Come on up. Yeah, Jake, I told you this before. Leave it alone. Leave it alone. Thank you. So first you find your boundaries. Nope, we're not doing it as an inequality. You can't do it that way. You don't know how to do it that way. Tell me what the other one is. Almost. This isn't right here. But that's way harder. Trust me. Absolute value of x equals 3. Tell me what the answers are. Find the boundary points. China, do you have them? Find the boundary points. Kate? It's 3 and negative 3. No, that's definitely not true. We want you to get this right. I'll help you. What can you put in here, Powers? Look at the equation.
It's 3 negative 3.
I know he knows it. Powers? No, you had absolute value of x. You can't have absolute value of x. X is 3 or x is negative 3. This is not solved. If you have an answer with an absolute value in it, it's not solved. Solving is telling me what x is going to be. That's not solved. What is x? Jake?
1.
No, 1. What's the absolute value of 1? Is that 3? What numbers can you put in here that make this true?
Negative x.
No. 3 or negative 3. Don't make it hard. No, Powers, what you wrote, this is what you wrote. Absolute value of x equals negative 3. That's wrong. We both said it. Well, I'm glad she knows that. This is not solved for x. In fact, can an absolute value be equal to a negative number? Powers? Can absolute value equal negative? No. Can't ever happen. You have to have it without the absolute value symbol. Seems picky, but you have to have the correct math. Because when the math gets harder, and it will, you're going to be in trouble. So here's a negative 3, and here's a 3. Anybody want to come up and finish this?
Sure, why not?
You going to do it, Joey?
No, why not? Hey, Miss Gombas, you know what my favorite commercials are? The Keo ones of the hamsters on them.
I'll tell you what my invention is. I have an invention, but I have to make it. I want to make a hamster ball for chihuahuas.
What?
I thought you were going to say I was going to make a hamster roll like the third.
Not for chihuahuas. Excellent.
That'd be kind of fun to watch them run around.
I'm going to look it up.
You're supposed to be doing math.
Human.
Okay, try 0. Does 0 make it true? And what you might have found that either absolute values will go in, Powers, or go out. Now that's memorizing, so I don't like it. If you test the regions, you'll know every time. So that doesn't work, so try 4. Is the absolute value of 4 bigger than 3? Yep. Try something to the left. Yes, it is. Absolute value of negative 5. What's the absolute value of negative 5? It's 5. Is 5 bigger than 3? Yeah. Yeah, you have to think a little bit to see which is bigger. That's true. Okay, Jens? I think that's it. Oh, no, we have one more. Oh, who wants to try that one?
Wait, I forgot what's the difference between and and or. So,
That's why we're not doing it.
or.
That's exactly why we're not doing it. This is going to be an or. Because x is less than negative 3 or x is greater than 3. But I don't care, because even in calculus, we don't care. So why I don't care there, why would I care now? Who wants to try this one? Katie, you want to try this one? Lexi, you want to try this one? Katie's going to do it? Why not? Well, you want to just talk? Well, after you get rid of the inequality, equals negative 2. Can't do it there. We're not doing it with inequality. We're doing it with the equation. Because then I don't remember when do I reverse that inequality? That's another problem. Okay, let's try 6. What's the left side? Read what it says. What's still here? No, it says absolute value of x. Those bars matter. Okay, solve that. What's x? No, what numbers make this true? 6, 2, right. 6 and negative 6. Now you got it. Good. Well, I don't know which way it's going to be. So now draw your line. We're not done. You got the boundaries. Put your boundaries in. Ah, you picked up the pen on me. Okay, it works. Put in negative 6 and 6. You guys should all be ahead of him. Actually, you should be doing this yourself. Are you done? Without telling him which way does it go. No, that's wrong. Because you know why? You didn't check it. Okay, he's got these filled in, I think. Not positive. And then check 0. Does 0 work? Is 0 minus 8 greater than or equal to negative 2? Powers? Is negative 8 bigger than negative 2? No. So it goes this way. That's the reason why your method isn't as good as my method. You just have to trust me. I've been doing this for 35 years. Actually, I haven't been teaching this way for 35 years. I learned a few years ago that this is the best method, and it works on wonderful problems. If you want to do something hard, 5 over x minus 2 is greater than 1. It's not that hard. First, you have to do this. No. You do equals 1. And then you test the regions. No, it's 5 over x. So 5 over x is equal to 3. And then we can cross multiply. So 3x equals 5. I was trying not to have fractions. Let's make that a 6. Then x equals 2. And actually, you have to do an absolute value. I forgot that. So you're going to get 2 answers from the absolute value, and there's a third one, can't divide by 0. So your things are, what was that going to be? 2, 0, 2, and I don't know where the other one is, someplace over here. And you just test all the regions. And there are 2 regions that work, 1 that doesn't. But you can't just look at it and do it. China, where are you going? Oh, okay. Answer your question. Answer your questions, yes. Must not have needed to go that badly. Okay.